The year is 2025. At precisely 9:18 a.m. Martian local time, NASA's Perseverance rover documented an anomaly in the Martian sky. The space agency subsequently disseminated the image via their official multimedia portal, revealing an object conspicuously outlined in green by NASA itself. This was no amateur photograph, nor a blurry snapshot from a fringe theorist. It was an official image from the rover's upward-facing skycam, capturing an extraordinary sight. 24 hours later, on October 3rd, 7 orbiting observatories from 4 distinct space agencies were ideally positioned to record the most intimate and high-definition imagery ever obtained of the celestial wanderer known as 3E Atlas. Following this, a profound silence descended. 4 days elapsed with absolutely no data released from NASA, China, or the UAE. Then, on October 7th, the European Space Agency finally broke the quiet. They unveiled images, faint, amorphous white specks, depicting a comet with a discernible coma, a standard, unremarkable appearance, precisely as anticipated. However, the true disquiet stems from the disparity. If ESA's imagery presented something sufficiently routine for immediate publication, why the continued reticence from NASA, China, and the UAE? Why has NASA not shared the Perseverance captures from October 3rd? Why has China, known for releasing thousands of Mars images annually and always eager to showcase its technological prowess, remained silent regarding observations from Tianwen-1? ESA presented a nebulous point of light and stated, "We require weeks, even months, for thorough analysis." What did the other agencies observe that they are completely unable to disclose? Consider the known facts. The object's orbital path defies conventional astrophysical calculations, possessing a probability of occurring of 1 in a million. It exhibits anomalous metallic emissions, contradicting fundamental physical laws. Furthermore, its age predates our entire solar system. Within 21 days, it will traverse behind the Sun, becoming entirely obscured from terrestrial telescopes precisely when solar radiation is expected to either disintegrate it or, if certain hypotheses hold true, provide an opportune cover for subsequent events. NASA provided a visual on October 2nd. 7 spacecraft documented an event on October 3rd. ESA offered indistinct smudges on October 7th. Meanwhile, the agencies equipped with the most sophisticated optics, highest resolution instruments, and most granular data remain conspicuously tight-lipped. The paramount inquiry is not the identity of 3 Atlas itself, but rather, what did NASA and China witness that ESA either missed or deliberately omitted? If this enigma captivates you as it does me, please like this broadcast and subscribe for continuous updates. In the comments section below, share your location, the local time, and whether you believe ESA's disclosure amplifies or mitigates the suspicions surrounding these events. To bolster our growing community, please share this content across X, Facebook, Reddit, or your preferred messaging platform. Your unwavering support is deeply appreciated. Bonus chapter, Urgent News Update. Before proceeding, a brief annotation. This segment was appended subsequent to the initial recording. On October 7th, 2025, mere hours after the conclusion of the main narrative, the European Space Agency issued its inaugural official images and data pertaining to the October 3rd Mars flyby. This breaking development fundamentally alters the trajectory of our story. Therefore, this supplementary chapter has been included to detail ESA's revelations and, crucially, to highlight what information they continue to withhold. Let us now delve into our updated understanding. The prolonged silence has finally been partially broken. The wait, at least in part, is over. On October 7th, 2025, the European Space Agency took a decisive step that NASA, China, and the UAE have yet to emulate. They released visual records. They published collected data. They shattered the silence that had enveloped this narrative since October 3rd. Yet, the essence of this development lies in its duality of revelation and frustration. The disseminated information generates as many questions as it purports to answer. Moreover, the data that remains unreleased may prove even more significant than that which has been disclosed. Let us commence with the evidence presented by ESA. The ExoMars Trace Gas Orbiter, utilizing its CASIS camera, the Color and Stereo Surface Imaging System, captured a series of images between October 1st and 7th. These have been compiled into an animated sequence, a GIF, illustrating the comet's movement against the backdrop of fixed stars. And there it is, 3 Atlas, a faintly discernible white dot near the center of the frame, traversing downwards through the field of view. This is ESA's official characterization, a slightly fuzzy white. Before succumbing to disappointment, it is imperative to comprehend the nature of this observation and the exceptional challenges it presented. CASIS was engineered for imaging Mars, optimized for capturing the planet's bright surface from distances ranging from a few hundred to a few thousand kilometers. Its design is focused on detailing geological formations, surface textures, and color variations in Martian rocks and regolith. 3E Atlas, however, was situated 30 million kilometers away, 100-fold farther than CASIS typically operates. Furthermore, unlike the resplendent Martian landscape, the comet is exceedingly faint. Nick Thomas, the principal investigator for the CASIS camera, attested that 3.2 Atlas is approximately 10,000 to 100,000 times less luminous than the instrument's usual targets. Its detection alone necessitated 5-second exposures, an exceptionally protracted duration for this particular camera. The captured images do not depict the nucleus itself. At a distance of 30 million kilometers, resolving the nucleus, which may only span a few kilometers, would be akin to attempting to discern a mobile phone on the moon from Earth, an impossibility for this instrument. What we are observing is the coma, the diffuse envelope of gas and dust enveloping the nucleus. ESA reports that the coma measures a few thousand kilometers in diameter, a substantial dimension. This confirms that 3 Atlas is actively outgassing, releasing volatile substances as solar radiation warms its surface. This is entirely consistent with typical cometary behavior. A comet approaching the Sun naturally develops a coma, which expands and intensifies with proximity. Notably, the images do not yet reveal a tail. Cometary tails form as solar winds expel gas and dust from the nucleus, creating the spectacular, extended streamers visible in space. However, tails are considerably fainter than comas. At the time of these observations, any existing tail was too faint for CASIS to register. ESA notes that a tail might become evident in subsequent imaging as the comet continues to heat up and exhibit increased activity. To date, there is nothing exceptional or anomalous. It appears to be a comet behaving precisely as expected. One might even deem it anticlimactic, given the preceding speculation and anticipation. However, this is where the narrative becomes particularly intriguing. The meticulous phrasing within ESA's announcement subtly reveals what is being withheld as much as what is being shared. Mars Express, ESA's other Martian orbiter, also attempted to observe 3 Atlas, but the comet has yet to manifest clearly in those images. The exposure time was constrained to half a second, the maximum feasible for the Mars Express camera, contrasted with the 5 seconds employed by ExoMars. This abbreviated exposure rendered the comet too dim to be definitively perceived. Nevertheless, ESA scientists are presently engaged in combining multiple Mars Express images, effectively stacking them to enhance the faint signal against the background noise. This is a standard astronomical methodology. When an object is too indistinct in a single exposure, numerous images are acquired and superimposed. The signal's intensity increases, while the noise is averaged out, allowing features to emerge. The rationale behind this endeavor? If the ExoMars images already offer sufficient clarity to confirm the comet's presence and its coma, why undertake the effort of processing Mars Express images for supplementary data? The answer lies in their pursuit of something specific, something that they hope further observations will either reveal or definitively disprove. Furthermore, there is the matter of spectroscopy. Gazer attempted to employ 3 distinct spectrometers to analyze the light emanating from 3 Atlas. Mars Express is equipped with Omega and SpyCam, while ExoMars TGO carries Nomad. All 3 instruments were directed at the comet during the flyby period. Spectrometers function beyond mere image capture. They deconstruct light into its constituent wavelengths, thereby elucidating the chemical composition of the light-emitting or light-reflecting source. Herein lies the ambiguity in ESA's communication. They have not explicitly stated whether spectroscopic data was successfully obtained. The announcement declares that, at this juncture, it remains uncertain whether the coma and tail were bright enough for spectral characterization. Uncertain, not a definitive affirmation or negation. This uncertainty carries immense weight. If high-quality spectral data were acquired, it would reveal the object's chemical makeup. They would know if the nickel signature is present, if the prevalence of carbon dioxide is confirmed, or if there are unusual elements or compounds that deviate from natural expectations. If this knowledge exists, they are presently electing not to disseminate it, opting instead to state the uncertainty of data acquisition rather than the implications of the data itself. The announcement concludes with a projected timeline. Scientists will continue their data analysis over the ensuing weeks and months. Not days, not an immediate preliminary report, but an extended, meticulous examination, taking their time to ascertain the composition and behavior of 3 Atlas. Thus, what has ESA verifiably provided? They have confirmed the comet's existence. They have verified the presence of a coma. They have presented imagery that, at first glance, appears entirely consistent with conventional cometary activity. They have broken their silence just enough to assert, yes, observations were made. Yes, it is present. Yes, it resembles a comet. However, they have been extremely judicious in refraining from any definitive pronouncements regarding composition, unusual characteristics, or anomalies. Those answers, if they exist, are being reserved for further scrutiny. Now, let us contemplate the potential motivations behind ESA's release. While NASA and China continue their silence, several plausible explanations emerge, which are not mutually exclusive. Firstly, ESA may genuinely possess the least compelling data. While ExoMars and Mars Express are advanced spacecraft, their cameras and spectrometers are not as powerful as some of NASA's sophisticated instruments. NASA's Mars Reconnaissance Orbiter, for instance, is equipped with the HiRISE camera, which should have captured images of significantly higher resolution. If these high-resolution images reveal something unexpected, necessitating careful analysis before public dissemination, NASA might be delaying. In contrast, ESA, with less detailed observational capabilities, may feel comfortable proceeding with publication. Secondly, ESA operates independently of any potential U.S. government shutdowns. They are not subject to furloughs, budgetary disputes, or political complexities. If they concluded their preliminary analysis and deemed their data ready for release, they could simply publish it without bureaucratic impediments or the need to coordinate with agencies currently experiencing staffing shortages. Thirdly, and this is purely speculative, ESA might be exerting subtle pressure on NASA and China by releasing their findings. Even if preliminary, their observations establish a baseline. They are effectively communicating. This is what we observed. This is what we are willing to share. Now, what about you? This generates public anticipation and amplifies the conspicuous nature of the continued silence from other space agencies. The crucial question that should now be posed is, if ESA's imagery depicts a seemingly normal comet with a typical coma and no overt anomalies, why do NASA and China persist in their silence? Why has NASA not released the Perseverance images from October 3rd? Why has China not published any data from Tianwen-1? And why is the UAE's HOPE orbiter data still unreleased? ESA has demonstrated that observations were indeed conducted and that they are publishable. So, what is preventing the other agencies from doing the same? Colin Wilson, ESA's project scientist for Mars Express and ExoMars, offered a noteworthy comment within the announcement. It's always extra exciting to see the orbiters responding to unexpected situations. Unexpected. This word choice warrants examination. 3 Atlas was predicted months in advance. Its flyby was meticulously scheduled, and spacecraft were deliberately positioned for observation. What aspect of this event could be considered unexpected? The trajectory was not unforeseen. The arrival date was not surprising. The fundamental occurrence of an interstellar comet passing Mars was not unanticipated. Therefore, to what does unexpected refer? Perhaps it pertains to the comet's behavior, its appearance, or some element within the data that deviated from predictions. We are, in essence, interpreting omens, scrutinizing word choices, and searching for subtle hints within what is stated and what is conspicuously omitted, as this is the extent of our current information. They have provided faint white dots, carefully chosen language, and a promise of further analysis in the coming weeks and months. The silence has been broken, but in the most restrained manner possible. Just enough to confirm that observations took place. Just enough to exhibit a standard cometary appearance. Merely sufficient to render the continued reticence of NASA, China, and the UE even more pronounced than before. Whatever was observed, whatever data those other spacecraft captured, it is still being withheld. And ESA's release, rather than resolving questions, may have intensified the most critical inquiry. If what ESA has shown us is sufficiently unremarkable to warrant immediate publication, what did the other agencies observe that necessitates weeks or months of analysis before any public disclosure is possible? Chapter 1. the 9 spacecraft holding the truth. Let us begin with what is definitively established. On October 3rd, 2025, at 0400 Coordinated Universal Time, the interstellar object designated 32 Atlas achieved its closest proximity to Mars. The distance recorded was 29 million kilometers. In astronomical terms, this represents an exceptionally close encounter, affording an unparalleled opportunity, an event that occurs perhaps only once in a human lifetime. 7 spacecraft were strategically positioned in orbit around Mars at that precise moment. 7 sets of instruments, 7 distinct perspectives, representing 4 separate space agencies, all focused on the same target, all simultaneously acquiring data. The first is NASA's Mars Reconnaissance Orbiter, launched in 2005 and still operational after 2 decades in Martian orbit. Its premier instrument is the HiRISE camera, the high-resolution imaging science experiment. This camera possesses the capability to resolve objects as small as 30 centimeters from Martian orbit. However, for 32 Atlas, positioned 30 million kilometers away, the effective resolution would be approximately 30 kilometers per pixel. While this may not sound impressive, it is crucial to recognize that this constitutes the highest resolution imagery of an interstellar object ever achievable in the entire history of human astronomy. Contemplate this for a moment. Every other interstellar visitor we have detected, oumuamua in 2017, Borisov in 2019, was only captured as a distant point of light as it receded from us, already accelerating away. 3 Atlas, however, has been under observation since July, and on October 3rd, we had the ideal vantage point. The second spacecraft is the European Space Agency's Mars Express. Launched in 2003, it carries the high-resolution stereo camera, primarily designed for 3-dimensional mapping of the Martian surface. Yet, cameras are indiscriminate in their targets. Mars Express possesses the capacity to generate 3-dimensional structural maps of the comet's coma, the diffuse cloud of gas and dust surrounding its nucleus. This could elucidate the coma's shape, density distribution, and any asymmetries in its outgassing patterns. The third is another European vessel, the ExoMars Trace Gas Orbiter, a collaborative undertaking with Russia's Roscosmos. This mission is equipped with Nomad, the nadir and occultation for Mars Discovery Instrument, and Cassis, the color and stereo surface imaging system. Nomad is a spectrometer engineered to detect trace gases in Mars' atmosphere with extraordinary sensitivity. However, when a spectrometer is directed at a comet, it analyzes something far more compelling than Martian air. It scrutinizes the chemical composition of material originating from another star system, formed billions of years ago under conditions we can barely comprehend. Next, consider NASA's Mars Odyssey Orbiter, launched in 2001, making it one of the longest-serving operational spacecraft at Mars. Its THEMIS instrument, the Thermal Emission Imaging System, captures infrared data, measuring heat signatures. If 32 Atlas exhibited any unusual thermal activity, any unexpected energy output, or any localized hotspots that should not be present, THEMIS would detect it. The fifth spacecraft is one we have already referenced, Perseverance, the rover situated in Jezero crater on the Martian surface. Its sky cam, mounted atop the rover, already captured an anomaly on October 2nd. But what of October 3rd, the moment of closest approach? Perseverance is equipped with multiple cameras and spectroscopic equipment. It was the sole terrestrial observer with a direct line of sight. The sixth spacecraft is China's Tianwen-1 orbiter. This is where the situation becomes intriguing in a distinctly different manner. Tianwen-1 has been in orbit around Mars since February 2021. During this period, the China National Space Administration has released over 14,000 images from the mission. 14,000. They regularly publish their findings and publicize their achievements. Space exploration is a significant source of national pride, and China consistently leverages every opportunity to demonstrate its technological capabilities on a global stage. Yet, concerning 3 Atlas, there has been absolute silence. Not a single image, not a solitary data release, not even an acknowledgement of attempted observations. The seventh is the United Arab Emirates HOPE orbiter, also known as the Emirates Mars mission. HOPE carries the Emirates Mars infrared spectrometer, designed to study the Martian atmosphere, but fully capable of acquiring spectroscopic data on a passing comet. The UAE has demonstrated remarkable transparency with its mission data, sharing images, engaging in international collaboration, and making its findings publicly accessible. However, regarding 3E Atlas, a similar silence prevails. Now, it is essential to discuss what lies ahead, as this narrative is far from concluded. In many respects, it has only just begun. In late November, between the 2nd and the 25th, the European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, currently en route to the outer solar system, will direct its instruments towards 3E Atlas. JUICE will observe the comet after its closest approach to the Sun, post-perihelion, when it is expected to be most active, when solar heating has triggered maximum outgassing, and when any unusual phenomena are most likely to occur. However, there is a complication. JUICE's current position relative to the Sun presents a communication challenge. The data it collects in November will not be transmitted back to Earth until February 2026, a 4-month delay, during which speculation about JUICE's findings will undoubtedly persist. Furthermore, there remains the possibility, still under active consideration, of rerouting NASA's Juno spacecraft for a close encounter in March 2026. Juno is currently orbiting Jupiter, focused on studying the gas giant's atmosphere, magnetic field, and internal structure. However, Juno possesses sufficient fuel and functional instruments. 3E Atlas is projected to pass within approximately 54 million kilometers of Jupiter on March 16, 2026. A trajectory adjustment made in September of this year could position Juno for a flyby at a distance of roughly 25 million kilometers, closer than the Mars encounter. This proximity would be sufficient for detailed imaging and spectroscopy, potentially answering some of the perplexing questions that are keeping astronomers awake at night. However, NASA has not yet approved this maneuver. Given the ongoing government shutdown, the furlough of 15,000 NASA employees, and the agency's operational paralysis, this critical decision is currently caught in bureaucratic stagnation. Consequently, we have 7 spacecraft that observed the October 3rd flyby, 1 spacecraft that captured preliminary images on October 2nd, and planned future observations for November and potentially March of next year. From this extensive array of instruments, agencies, and data, what has been made public? One image from Perseverance's SkyCam, taken on October 2nd and published on NASA's raw image page, showing an object in the Martian sky encircled in green. And thereafter, nothing. Chapter 2. The Perseverance SkyCam images, captured on the 2nd day of October, warrant discussion. What NASA has officially published is not conjecture or hearsay. These are legitimate photographs from the Mars 2020 Raw Image Archive. They are verifiable, bear timestamps, and are clearly labeled, accessible to anyone with an internet connection. This particular photograph was taken on Sol 1642, which represents the count of Martian days since Perseverance touched down in Jezero crater. Sol 1642 corresponds to October 2nd, 2025, by Earth's reckoning. The precise time logged is 9 hours, 18 minutes, and 48 seconds Mars local mean solar time, indicating morning on the red planet. The Sun had been visible for approximately 3 hours. The instrument responsible for this capture is officially identified as the Perseverance SkyCam. It is situated atop the rover's main deck, the flat expanse housing the majority of its scientific equipment. Unlike the forward-facing navigation cameras or the mast-mounted cameras that survey the horizon, the SkyCam is directed vertically upwards. Its intended function is to observe the Martian atmosphere, monitor for phenomena like dust devils and clouds, and track changes in atmospheric density as dust storms form and dissipate. However, on October 2nd, it recorded something entirely different. The initial image reveals what appears to be a circular formation, slightly warped by the camera's wide-angle lens. A distinct entity is discernible in the upper portion of the frame. NASA's own image processing team has outlined this object in green. Let this detail resonate for a moment. This is not a casual observer pointing out a pixelated anomaly. This is an official NASA multimedia publication with an annotation added by NASA personnel, drawing attention to something within the Martian sky. The subsequent photograph offers a broader perspective, showcasing more of the SkyCam's complete field of view. Within this frame, the camera's own circular housing is visible, along with the characteristic edge distortion from its fisheye design. And there, in the upper right quadrant, the same object makes its reappearance. It is faint, yet it is present. It is not a defective pixel, nor is it the result of a cosmic ray impact or a processing artifact. Its presence in multiple frames and its apparent displacement between them signifies genuine movement relative to the camera. What makes this technically noteworthy is that the Skycam is not engineered as a high-resolution instrument. Its design prioritizes wide-field monitoring over detailed imaging of distant subjects. Its primary purpose is atmospheric observation, tracking phenomena in the Martian sky at relatively close proximity. The mere fact that it managed to detect 3I Atlas at all conveys significant information. It indicates that the object possessed sufficient brightness to be registered by a camera not intended for astronomical observation, bright enough to stand out against the Martian daytime sky. While this sky is considerably dimmer than Earth's due to Mars' attenuated atmosphere, it is far from the profound darkness of night. This observation was not made during Martian dusk or pre-dawn twilight. It was mid-morning. And yet, there it was. The approximate distance of 3I Atlas at the time of this image acquisition was 30 million kilometers. This represents the separation between 3I Atlas and Mars on October 2nd. For perspective, this is roughly 80 times the distance between the Earth and the Moon, a vast expanse of emptiness. And Perseverance's upward-facing camera, without any specific expectation of capturing anything other than Martian weather, detected it. Crucially, the timeline becomes paramount here. October 2nd did not mark the point of closest approach. That occurred 24 hours later, on October 3rd. The object was still in transit, still drawing nearer, and consequently, becoming brighter as it approached Mars. This then raises the question, what did Perseverance capture on October 3rd? The answer is unknown, as NASA has not yet released those images. Typically, the raw image archive for Perseverance is updated within a few days of image capture, sometimes even within hours. The rover generates thousands of photographs, which are transmitted to Earth via Mars orbiters acting as relay stations. This data reaches deep space network facilities in California, Spain, and Australia, is routed to the Jet Propulsion Laboratory in Pasadena, and subsequently uploaded to the public archive. This entire process is largely automated, not requiring human intervention to decide what is published. The images simply proceed through the pipeline and appear on the website. This operational method has been consistent for years. Images from Curiosity are uploaded with clockwork regularity, as are those from Perseverance. The only exception appears to be the images from October 3rd, the day of closest approach. These are the images that would have revealed 3I Atlas at its nearest point to Mars, at its brightest, and therefore, at its most observable by any human-made instrument. These crucial images are conspicuously absent. One might contend that Perseverance was occupied with its mission objectives, collecting rock samples, studying Martian geology, and searching for evidence of ancient microbial life. It operates on a schedule with defined priorities. It is possible the science team did not task it to observe 3I Atlas on October 3rd, perhaps focusing on drilling another core sample or navigating to a new location. However, this explanation is contradicted by the official mission plan, which confirms that multiple spacecraft were coordinating observations of 3I Atlas during its Martian flyby. This event was considered significant, and NASA publicly declared its intention to observe it. Furthermore, Perseverance is equipped with numerous cameras capable of being directed skyward at any point during the Martian day on Sol 1643, which corresponds to October 3rd. The rover does not need to cease its operations to capture a skyward image. It can perform both functions simultaneously. The Skycam is perpetually active, continuously pointed upwards, always ready to record anything passing overhead. Therefore, the question remains, where are these images? There is another pertinent detail worth examining. The photograph from October 2nd was not prominently highlighted or featured by NASA. It was not disseminated with a press release, nor was it included in any mission updates or news articles. It simply appeared within the raw image archive, alongside thousands of other images, accompanied by basic metadata and no commentary. The green circle annotation was added retrospectively, presumably by an individual browsing the archives who noticed the object and brought it to attention. NASA's multimedia team frequently annotates noteworthy images, identifying geological features or unexpected atmospheric phenomena. This is standard procedure, but the timing in this instance is intriguing. Following the addition of the annotation and the subsequent circulation of the image on social media, a profound silence descended. One might also contemplate the images from the orbital spacecraft, as Perseverance was not the sole camera directed towards 3I Atlas that day. The Mars Reconnaissance Orbiter, Mars Express, and Odyssey were all in position. These orbiters possess significantly more powerful cameras than a rover's Skycam, and consequently, should have captured substantially superior images. And perhaps they did. We simply have not seen them. A pattern is emerging, and it is not subtle. On October 2nd, one day prior to the closest approach, an image surfaces depicting 3I Atlas in the Martian sky. It is automatically published as part of the routine data flow. Someone notices it, annotates it, and it begins to garner interest. Then, on October 3rd, the day of closest approach, when 7 spacecraft were simultaneously observing, and when we should have been presented with the most remarkable images ever obtained of an interstellar object, nothing is released. This applies to images from Perseverance, the Mars Reconnaissance Orbiter, Mars Express, Odyssey, and all other participating missions. The automated data stream appears to have ceased flowing, or more accurately, it is being deliberately held back, as data does not simply vanish. It exists, presumably on hard drives at the Jet Propulsion Laboratory, on servers at the European Space Operations Center, and within the archives of the China National Space Administration. It is tangible. We are simply being denied access to it. The question then becomes, why would NASA publish an image on October 2nd, permit its annotation and distribution, and then withhold all subsequent data? There are fundamentally two conceivable explanations. The first is the realm of mundane operational issues, data corruption, communication interruptions, or a government shutdown impacting routine functions. Perhaps the images are languishing in a queue, awaiting processing by furloughed personnel currently unavailable. It is possible there is a perfectly rational explanation devoid of any connection to the actual content of the images. The second possibility is less ordinary. The images likely depict something extraordinary, something that necessitates careful analysis before public disclosure, something that might require deliberation and coordination among multiple space agencies before any official statement is made. The image from October 2nd presents an object in the sky, a mere point of light, and nothing more. However, points of light do not typically warrant coordinated efforts between NASA, ESA, CNSA, and the UAE. Points of light are generally published automatically, analyzed by the scientific community, and openly discussed in academic papers and press releases. So, what did the camera observe on October 3rd that a simple point of light on October 2nd did not prepare anyone for? What transpired in those 24 hours as 3I Atlas drew nearer, as the resolution improved and the details became clearer? We do not possess the answer. However, 7 spacecraft do, and 4 space agencies do. And within secure facilities across 3 continents, individuals are examining images to which we are not privy. Chapter 3. 4 Days of Silence. What transpired thereafter? Today is October 7th, 2025. Exactly 4 days have elapsed since the closest approach. 96 hours have passed since 7 spacecraft observed 3I Atlas at the highest resolution ever achieved for an interstellar object. And throughout these 96 hours, the silence from the world's space agencies has been, to put it mildly, profound. Let us first establish what constitutes normal protocol. To comprehend the significance of this silence, one must understand its deviation from standard operating procedures. When Mars missions acquire noteworthy data, it is typically released promptly. NASA's Mars Reconnaissance Orbiter routinely publishes high-resolution images of the Martian surface, often within days of their acquisition. These are not merely routine mapping photographs. They are detailed observations of dust devils, avalanches on crater walls, newly formed impact craters, and seasonal shifts in the polar ice caps. These images are published on NASA's website with accompanying explanatory captions, featured in press releases, and shared on social media by NASA's Public Affairs Office. The European Space Agency follows a similar protocol with its Mars Express mission. When the spacecraft captures something remarkable, such as a dust storm, a mineral deposit, or an unusual geological formation, ESA disseminates this information. They publish articles, provide context, and invite planetary scientists to offer their insights. The information flows outward to the public as a matter of routine. However, the situation becomes particularly intriguing when considering China's approach. The China National Space Administration is arguably even more aggressive in promoting its space achievements. CNSA views space exploration as a manifestation of national prestige, with every successful landing, orbital insertion, and scientific discovery serving as an opportunity to showcase technological prowess to the global community. When Tianwen, 1 entered Mars orbit in February of 2021. CNSA released images within hours. When the Zhurong rover successfully landed on the surface in May of the same year, high-resolution, color-corrected, and professionally processed images were made available immediately. Since Tianwen-1's arrival at Mars, CNSA has published over 14,000 images from the mission. 14,000. This equates to an average of nearly 12 images per day for 4 consecutive years, depicting the Martian surface, the rover's tracks, rocks, dunes, and even the Chinese flag painted on the lander. They showcase everything, as demonstrating their capability to compete on equal footing with NASA and ESA is paramount. Therefore, when 3I Atlas, the most significant interstellar object to traverse our solar system in recorded history, came within 30 million kilometers of Mars, what did CNSA release? Nothing. Not a single image, not a data set, not a press statement, and not even an acknowledgement that Tianwen-1 attempted any observations. This behavior is entirely uncharacteristic of CNSA and contradicts every pattern they have established over their 4 years of Mars operations. Had Tianwen-1 captured images of 3I Atlas, and had those images revealed precisely what was anticipated, a typical comet with a standard coma and tail, CNSA would have published them instantly. They would have celebrated the capture of an interstellar visitor and utilized it as evidence of their advanced imaging capabilities. In all likelihood, they would have preempted NASA and released their data first, simply to demonstrate that China achieved this before America. But they remained silent. Utterly and completely silent. One might suggest that the United States government shutdown provides an explanation for NASA's reticence. To a degree, this is a valid point. As of October 1, 2025, more than 15,000 NASA employees were furloughed, representing 83% of the agency's workforce. The Jet Propulsion Laboratory, which manages the majority of NASA's Mars missions, is currently operating with a minimal skeleton crew. Data processing pipelines that normally function seamlessly are now progressing with extreme bureaucratic slowness. However, this explanation presents a significant flaw. The government shutdown affects only the United States. It has no bearing on the European Space Agency, the China National Space Administration, or the United Arab Emirates Space Agency. These are independent entities situated on different continents, with distinct funding structures and divergent political landscapes. ESA's budget is derived from its member states within the European Union. CNSA reports to the Chinese Communist Party. The UAE's space program is financed by the Emirati government. None of these agencies are subject to American budgetary disputes, nor do they have furloughed employees. Consequently, they possess no operational rationale for delaying the release of data pertaining to 3I Atlas. Yet, they remain silent. CNSA is silent. The UAE is silent. This is where we must address the nature of coordination within the space community, as these agencies do not collaborate on all matters. In fact, they rarely coordinate on anything beyond basic safety protocols and frequency allocation to prevent interference with each other's communications. NASA and CNSA, in particular, maintain a relationship that can best be characterized as competitive rather than hostile. Legal restrictions are in place governing cooperation between American and Chinese space programs. The Wolf Amendment, enacted by the U.S. Congress in 2011, prohibits NASA from utilizing federal funds to engage in cooperative space activities with China without explicit congressional authorization. This effectively means that NASA and CNSA do not freely exchange data, engage in joint missions, or coordinate their scientific announcements. They compete, they monitor each other, and they strive to surpass each other's achievements. When China successfully lands a rover on the far side of the moon, NASA responds by accelerating its Artemis program. When NASA lands Perseverance on Mars, China counters by landing Zhurong. This is the established dynamic, the operational framework. Therefore, when both NASA and CNSA fall silent simultaneously regarding the same event, this is not indicative of normal competition. It signifies coordination, something entirely different. The same logic applies to ESA. While ESA and NASA collaborate on numerous projects, they remain distinct entities with independent priorities. When ESA possesses compelling data, they publish it autonomously, without seeking NASA's approval or consulting Washington before releasing Mars Express images. They operate independently. However, this time is an anomaly. This time, ESA remains silent while NASA remains silent, while CNSA remains silent, and while the UAE remains silent. for agencies, for continents, for distinct political systems, all maintaining silence concerning the same event. There is a pertinent idiom for this situation. When everyone talks, nobody listens. When everyone stays quiet, everyone hears the silence. Consider the immense effort required to achieve this level of coordinated silence. Envision the conversations that must have taken place. NASA officials reaching out to their ESA counterparts, ESA contacting CNSA, and someone coordinating with the UAE. This implies an agreement that nothing would be released until precisely when? Until everyone had sufficient time to analyze the data, until everyone agreed upon its interpretation, and until everyone had decided on the method of public presentation. These are not discussions that occur for routine observations, nor are they typical for a standard cometary passage through the solar system. These are the kinds of conversations that transpire when something unexpected emerges in the data, and no one wishes to be the first to vocalize it. There is a predictable pattern in the handling of scientific anomalies. When an unusual finding appears in data, the initial impulse is not to publish immediately. The primary instinct is to verify, to confirm, and to ensure with absolute certainty that the observation is genuine, rather than an instrument malfunction, a processing error, or a cosmic ray event that coincidentally appeared unusual. Consequently, diagnostics are run, data is reprocessed, calibration standards are consulted, and colleagues are invited to review the findings. Every plausible mundane explanation is meticulously and systematically ruled out before even considering the possibility of something genuinely anomalous. This is the hallmark of sound scientific practice, the correct methodology. The issue, however, is that this process typically does not necessitate the coordination of silence among 4 independent space agencies, unless, perhaps, they all encountered the identical anomaly, requiring verification from all parties and an absolute certainty before any public statement is made, because once uttered, it cannot be retracted. And so, here we are, on October 7th, 4 days after the closest approach. The data exists somewhere within JPL's servers, within ESA's archives, within CNSA's databases, and within the UAE's mission control systems. There are images, high-resolution images, spectroscopic data, thermal readings, everything that 7 spacecraft captured during those critical hours when 3I Atlas was at its closest point to Mars. And not a single byte of this information has been shared with the scientific community or the public. The SkyCam image from October 2nd remains the sole visual evidence we possess. A point of light in the Martian sky, captured 1 day before the closest approach, 1 day before the resolution improved by orders of magnitude, 1 day before whatever it was that prompted 4 space agencies to decide on a strategy of silence until they could ascertain its nature. The silence persists, and with each passing day, this very silence becomes the most potent communication being made. Chapter 4. What it could actually be. The theories. While we await the space agencies to break their silence, let us explore the potential nature of 3I Atlas. The answer to this question will determine whether we are witnessing a routine astronomical event or something that will fundamentally alter humanity's understanding of its place in the cosmos. Currently, 4 primary theories are being debated, ranging from the conventional to the extraordinary. Each theory is supported by some evidence, yet each also presents challenges. Comprehending all 4 is crucial to understanding why the silence from those who have analyzed the October 3rd data might be so rigorously maintained. Theory 1. The Ancient Scout Ship. This concept has gained considerable traction in certain online communities. While it may sound like pure science fiction, the underlying mathematical principles are surprisingly robust. The theory posits that 3I Atlas is not a natural celestial body. This is an exploratory craft, a vessel, sent forth by an advanced civilization, somewhere within the Milky Way galaxy, between 7 billion and 14 billion years in the past. To provide some context, our own star, the Sun, is merely 4.6 billion years old. Earth, our planet, has existed for approximately 4.5 billion years. The emergence of the first complex, multicellular life forms on Earth occurred around 600 million years ago. Anatomically, modern humans have been around for perhaps 300,000 years. However, the object designated 3I Atlas might predate all of these milestones. It could have been constructed and launched when the universe was less than half its present age. This was a time before our solar system even existed, when the very elements that would eventually coalesce to form Earth were still dispersed across interstellar Space in vast clouds of gas and dust. What would compel a civilization to undertake the creation of such an object? One compelling hypothesis suggests it functions as an observational probe, a celestial recorder, a device dispatched to traverse the galaxy, documenting cosmic phenomena and accumulating data across immense geological epochs. It's not envisioned as a vessel carrying a crew, nor one intended for a return journey, but rather an autonomous system, perhaps powered by principles of physics yet unknown to us. It might remain dormant for eons, awakening only upon encountering something of significant interest, such as a solar system, planets within a habitable zone, or even life itself. Alternative interpretations of this theory posit that 3-2 Atlas serves as an interstellar arc. However, instead of carrying living organisms, it might bear information, accumulated knowledge, and advanced technologies, the enduring legacy of a civilization aware of its impending demise, striving to ensure some part of its existence would persist. It could be akin to a message in a bottle, cast into the cosmic ocean countless ages ago, now reaching our shores. The timing of its arrival is particularly noteworthy. 3-2 Atlas is estimated to have entered the outer reaches of our solar system approximately 8,000 years ago. This coincides remarkably with the dawn of human civilization's ability to maintain written records. It was during this era that the first cities began to rise in Mesopotamia, and the advent of agriculture transformed nomadic groups into established societies. If one were to design an observational probe tasked with monitoring the development of an intelligent species strategically, placing its arrival at this particular juncture would be logical, not so early as to find nothing of interest, and not so late as to miss the crucial period of transition. This notion instills unease in some, for if it holds true, it implies we have been under observation for millennia, entirely unaware of it. Theory 2, an active reconnaissance mission. This perspective shares similarities with the first theory but suggests a more immediate and purposeful intent. Instead of an ancient artifact drifting passively for billions of years, this theory proposes that 3-2 Atlas was deliberately dispatched to our solar system with relative recency, perhaps within the last few million years, by a civilization that detected our sun and sought a closer examination. The object's trajectory lends credence to this idea. It is not merely passing through in a random fashion. Its path aligns almost perfectly with the ecliptic plane, the planar disk within which all the planets orbit the sun. Furthermore, its trajectory is set to bring it in close proximity to multiple celestial bodies, Mars in October and Jupiter in March. If one were engineering a reconnaissance mission to sample diverse planetary environments and observe various types of worlds within a single solar system, this exact path would be meticulously chosen. The retrograde orbit, moving in the opposite direction to the planet's revolution, is another significant piece of evidence. This orientation is actually advantageous for a reconnaissance mission, as the object traverses the solar system. The planets effectively come to meet it. Should it need to deploy smaller probes or auxiliary observation devices, its retrograde motion would enable these dispatches with minimal energy expenditure while still ensuring an interception of planetary orbits. The planet's own orbital velocities would accomplish a substantial portion of the task. Loeb, a prominent astrophysicist at Harvard who has been closely monitoring this object, has characterized it as a potential cosmic flyby probe. Its purpose may not be inherently hostile or benevolent, but purely observational. It could represent a civilization conducting a galactic survey, gathering data on planetary systems, with our own solar system merely one stop on its extensive itinerary. Theory 3, a natural comet with exotic chemistry. This is the prevailing scientific explanation, the default assumption held by the majority of astronomers. 3-2 Atlas, in this view, is simply a comet. It originated in the outer reaches of the Milky Way, was ejected by gravitational interactions with planets or passing stars, and has been wandering through interstellar space ever since. Its current passage through our solar system is purely coincidental. There is nothing intelligent or deliberately designed About it, it is merely a celestial body, composed of ice, rock, and frozen gases, behaving as such bodies are expected to. Its unusual chemical composition can be attributed to formation conditions, distinct from those found within our own solar system. 3-2 Atlas likely originated from the Milky Way's thick galactic disk, a region characterized by older stars with differing metallicities, elemental abundances, and consequently, different conditions during planetary formation. Comets formed in such environments might exhibit variations in their chemical makeup, perhaps with higher concentrations of carbon dioxide, less water, different metallic ratios, and a distinct assemblage of volatile compounds. While unusual, this is not impossible, merely a representation of different natural processes. The object's trajectory, from this perspective, is a statistical anomaly. While the odds are low probability does not equate to impossibility. In a galaxy containing hundreds of billions of stars, each potentially ejecting comets into interstellar space, it is statistically inevitable that at some point, one such object will possess a trajectory that appears suspiciously purposeful purely by random chance. This might be that singular instance. The advantage of this theory lies in its avoidance of extraordinary assumptions. It requires no postulation of ancient civilizations, no advanced technological artifacts, and no external intelligence. It simply describes nature operating according to its established principles, producing objects with an immense range of characteristics. Occasionally, one of these objects may exhibit peculiarities sufficient to spark human curiosity and speculation. Theory 4. The hybrid stealth craft. This is perhaps the most imaginative of the proposed explanations conceived by those contemplating how an advanced civilization might conceal its technology. The concept is both simple and ingenious. Rather than constructing an overtly artificial spacecraft, the civilization would identify a natural object, such as an asteroid or a comet, and hollow it out. The natural rock and ice would then serve as a protective shell and camouflage, concealing the actual technological apparatus within. From an external perspective, it would appear indistinguishable from a natural comet. It would exhibit a coma generated by the deliberate venting of gases to maintain the illusion. Its outgassing patterns would mimic natural phenomena, as they would be meticulously engineered. To do so, any telescope observing it would register exactly what is expected, a comet and nothing more. However, concealed within this natural facade would be intricate structures, advanced machinery, and a clear purpose. This theory effectively accounts for several observations. It explains why 3-2 Atlas might display some behaviors characteristic of comets while also exhibiting anomalies that deviate from the standard cometary model. It is, in essence, both a cometary exterior enclosing a technological core. This represents the ultimate disguise for interstellar travel, allowing passage through solar systems without attracting undue attention or triggering alarms, while executing its design mission under the guise of harmless debris. This hypothesis has been given serious consideration within astrobiology circles. It is plausible that if humanity were to develop its own interstellar probes, we might adopt a similar strategy, utilizing asteroids or comets as both a source of raw materials and as a means of concealment. Such an approach is both efficient and intelligent, and if we can conceive of it, it is highly probable that other civilizations have done so long before us. Thus, we have these four principal theories: the ancient artifact, the active reconnaissance mission, the natural comet with unusual chemistry, and the hybrid stealth craft. Each possesses supporting arguments and a following of proponents, and each leads to vastly different implications regarding our subsequent actions. Meanwhile, within secure installations where the data acquired on October 3rd is undergoing meticulous analysis, teams are scrutinizing images, spectroscopic readings, and thermal measurements, striving to determine which of these theories the evidence corroborates. Alternatively, they may be encountering data that defies all current models, perhaps revealing phenomena that necessitate the formulation of a fifth theory or a sixth, concepts not yet publicly disclosed because no one previously imagined their necessity. We can engage in speculation construct theoretical frameworks, perform probabilistic calculations, and participate in online debates. However, those who possess the definitive knowledge, those who have witnessed what 7 different spacecraft observed on October 3rd, remain silent. Not yet, and certainly not to us. And that silence, more than any speculative theory, strongly suggests that whatever 3-2 Atlas may be, its nature is significant enough to warrant extreme caution in how the truth is eventually revealed. Chapter 5. The million-to-one mathematical impossibility. Let us now turn our attention to numerical values, not the easily comprehensible figures we employ in daily life, but rather the unsettling numbers that compel astronomers to pay closer heed and pose questions they may not entirely wish to have answered. The trajectory of 3-2 Atlas is one that should not exist. Not that it is physically impossible, but rather that its probability of occurring through random chance is so infinitesimally small as to render the term unlikely an inadequate description. Here are the relevant parameters. On October 3rd, 2025, 3-2 Atlas passed within 29 million kilometers of Mars. On March 16th, 2026, it is projected to pass within 54 million kilometers of Jupiter. These are 2 planetary encounters involving 2 of the most scientifically compelling worlds in our solar system after our own, all within a single flyby and at distances sufficiently close for detailed observation. Let us dissect why this is mathematically extraordinary. Firstly, consider the alignment with the orbital plane. The ecliptic plane represents the flat disk within which Earth and the other planets orbit the Sun. It serves as the primary reference plane for our solar system. To visualize this, imagine our solar system as a vinyl record. The ecliptic plane is the surface of that record, and the planets trace grooves, spiraling towards the center. The majority of comets and asteroids native to our solar system orbit roughly within this plane, with minor deviations of a few degrees, a consequence of their formation from the same rotating disk of material billions of years ago. 3-2 Atlas, however, exhibits an inclination of 4.89 degrees relative to the ecliptic. This might not sound significant, less than 5 degrees, suggesting near alignment. Yet, herein lies the crucial point. For an object originating from outside the solar system, possessing no inherent connection to our system's formation history, there is no inherent reason for it to exhibit any specific alignment whatsoever. It could have originated from any direction in three-dimensional space, above the ecliptic, below it, or perpendicular to it. The overwhelming majority of possible trajectories would not bring it anywhere near the ecliptic plane. The probability of this specific timing, this alignment coinciding with the planetary encounters, is approximately 0.2%, or roughly 2 in 10,000. Now, we arrive at a truly unsettling calculation. These probabilities are independent events. The alignment with the ecliptic plane and the precise timing of the planetary encounters are distinct factors. To ascertain the probability of both occurring, we must multiply their individual probabilities. 0.2% multiplied by 0.002% yields 0.0004%. This equates to 4 in 1 million, or approximately 1 in 250,000. However, we are not yet finished. There remains a third critical factor. The trajectory does not merely pass near Mars and Jupiter, it does so in a manner that maximizes observational opportunities. The closest approach distances are meticulously calibrated, neither excessively close, which would result in the object passing too swiftly for adequate instrument observation, nor too distant, which would compromise resolution. The distances at which 3-2 Atlas maintains its closest approaches are, frankly, ideal for spacecraft observation. When this optimization of approach distances is factored into the calculation, the combined probability diminishes even further. Loeb has estimated this combined probability to be approximately 0.005%. That translates to 5 in 1 million, or 1 in 200,000. Consider what a 1 in 200,000 probability signifies. If you were to shuffle a standard deck of cards, and deal yourself 5 specific cards in a precise sequence. That event would be more probable than this trajectory occurring by chance. Purchasing a lottery ticket would offer you a greater chance of winning a significant prize than the likelihood of 3-2 Atlas following this particular path randomly. Let us now examine the 5-degree tilt, as this is where the mathematics becomes even more compelling. Why precisely 5 degrees? Why not a perfect alignment? At 0 degrees? Why not 10, 20, or some other arbitrary value? There exists a hypothesis that elegantly and perhaps disturbingly explains this specific inclination. It is referred to as the transit survey cone theory. Here is how it functions. Imagine yourself as an extraterrestrial civilization residing on a planet orbiting a star somewhere within the galaxy. Your objective is to detect other planetary systems. How would you achieve this? Precisely as human astronomers do, through transit surveys. You would observe stars and await the passage of planets in front of them, which results in minute dips in stellar brightness. This has proven to be the most successful method we have employed for discovering exoplanets, leading to the identification of thousands of worlds. However, there is a critical limitation. You can only detect planets that transit your star from your specific vantage point. If your observational alignment is incorrect, if you are not viewing the star from the optimal angle, you will not observe the transit. The planet might be present, but its presence would remain undetected. This implies that a narrow cone of space, a specific viewing angle, exists from which the planets in our solar system would be detectable via transit survey. If an alien civilization were situated within this cone, they could detect Earth, Mars, and Jupiter. From their perspective, they would observe all three, crossing the face of our sun. How wide is this cone? Its extent depends on the sensitivity of the detection criteria. If the objective is solely to detect Earth-sized planets, the cone would be relatively narrow, perhaps 1 or 2 degrees. However, if the interest extends to detecting all objects, including the asteroid belt, which forms a dense torus of debris situated between Mars and Jupiter, the cone would widen considerably. The asteroid belt spans approximately 150 million kilometers in thickness. From a distant vantage point, any objects transiting the sun from within this belt would be detectable. The mathematical calculations indicate a cone approximately 10 degrees in width. Any civilization located within this 10-degree band, either above or below the ecliptic plane, would be capable of detecting our asteroid belt, our major planets, and Earth. This would signify that our solar system warrants further investigation. Now, if you were such a civilization and decided to dispatch a probe to investigate our system, what trajectory would you select? You would likely launch it along the same alignment that facilitated your detection in the first place, sending it directly down the center of that cone. Such a trajectory would be inclined at precisely 5 degrees, representing the midpoint between 0 and 10 degrees. 3-2 Atlas is inclined at 4.89 degrees, effectively 5 degrees, taking into account measurement precision. This could be attributed to coincidence, but it is an exceptionally specific coincidence. It is not merely a general alignment. It is an alignment that makes perfect sense. If the object were deliberately targeted at our solar system by a civilization that detected us via transit survey, the immense mass of 3-2 Atlas adds another layer to this intricate puzzle. Based on its observed brightness and estimated size, the object's mass is at least 33 billion tons and potentially greater. For comparison, the International Space Station, humanity's largest orbital structure, has a mass of approximately 420 tons. The Space Shuttle, when fully loaded, weighed around 2,000 tons. SpaceX's Starship, the most massive rocket ever constructed, has a launch mass of 5,500 tons. 3-2 Atlas is 6 million times more massive than Starship. 6 million. If this object is artificial, if it was engineered rather than naturally formed, the level of engineering required surpasses anything currently within human capability by factors that render direct comparison almost meaningless. We are contemplating a civilization capable of manipulating billions of tons of material, accelerating it to interstellar velocities and guiding it along trajectories so precise as to navigate the vast distances between planets separated by hundreds of millions of kilometers. That is the degree of technological sophistication implied if 3-2 Atlas is indeed a probe. It is not merely beyond our current abilities, it is incomprehensibly beyond us. The disparity is akin to comparing a stone axe to a particle accelerator. Avi Loeb has meticulously compiled what he terms the 7 anomalies of 3-2 Atlas. The trajectory is catalogued as anomaly 6, but it is the anomaly that serves as the linchpin connecting all others. Because the trajectory dictates everything else, the object's destination, what it encounters, and when it encounters it. If the trajectory is deliberate and purposeful, then every other anomaly must be re-examined within that specific context. A natural comet exhibiting an improbable trajectory is an object of scientific curiosity. An artificial probe, following a meticulously calculated trajectory, however, represents something entirely different. It signifies that someone specifically aimed this object at us. It implies that someone desired its presence here. It suggests that someone is or was interested in our solar system in particular. The probability calculations, while compelling, do not constitute definitive proof. A 1 in 200,000 chance is indeed unlikely, but it is not an impossibility. Unlikely events do occur. People win lotteries. Lightning can strike the same place twice. Cosmic coincidences do manifest. However, when operating as a space agency, whether NASA, ESA, or CNSA, and reviewing data from October 3rd, observing an object with a 1 in 200,000 trajectory exhibiting unexpected behavior, something that does not perfectly align with the established cometary model, one naturally begins to pose difficult questions. Questions about whether to publish the data immediately or to dedicate time to fully comprehend what is being observed. Questions about whether the trajectory itself is communicating a message. Questions about whether whoever or whatever sent this object, if indeed it was sent, intended for us to notice, intended for us to wonder, intended for us to ask precisely these inquiries. The mathematics are unassailable. The trajectory is what it is. The probability is what it is, 1 in 200,000. These are the numbers. What these numbers signify, and the conclusions we derive from them, are the questions that keep astronomers sleepless. And somewhere within the data, from October 3rd, within the images that we have not yet been permitted to view, there may lie the answer concerning an interstellar object that arrived by chance with an orbital plane within 5 degrees of the ecliptic. That's about 0.2% or 2 in a thousand. Already quite unlikely, but we are only just beginning. Now, regarding the timing, 3-2 Atlas did not merely cross the ecliptic plane, it did so at precisely the locations required to encounter Mars and Jupiter. Consider what this entails. Mars orbits the Sun at an average distance of approximately 230 million kilometers. Jupiter orbits at roughly 780 million kilometers. For 3-2 Atlas to pass close to both planets, it needed to intersect their orbital paths at the exact moment. These planets were present at those intersections, not on the opposite side of the Sun, not months in advance or behind, but precisely there at the moment of the object's passage. Chapter 6, October 29th, the hidden moment of truth. There is a date circled on calendars in observatories across the globe. October 29th, 2025, just 22 days from now. That is when 3-2 Atlas is scheduled to reach perihelion, its closest approach to the Sun. This will occur at 1.36 astronomical units, approximately 203 million kilometers, just inside the orbit of Mars and slightly outside the orbit of Earth. And here is the critical aspect that makes this date so significant, so potentially revealing, and so frustratingly inaccessible. 3-2 Atlas will be entirely obscured from the view of every telescope on Earth. The geometric configuration is straightforward but unavoidable. As the object approaches its perihelion from Earth's perspective, it will be moving directly towards the Sun. It will then pass behind the Sun. Subsequently, if all proceeds as anticipated, it will re-emerge on the opposite side in late November. However, during this closest approach, during the period when solar radiation is at its zenith, when the comet should be at its most active, and when any anomalous phenomena are most likely to manifest, we will be unable to observe it. The sun will physically obstruct our view, literally positioned between us and the object we are attempting to observe. This situation represents more than a mere inconvenience. It constitutes a critical observational lacuna. Perihelion is precisely when comets typically reveal their true nature. When situated far from the sun, they remain cold, inert, and dormant. The volatile substances, the frozen gases locked within their ice, stay frozen. Outgassing and activity are minimal. They are essentially dark masses of material drifting through space. As the object draws nearer to the sun, the escalating solar radiation triggers a profound transformation. The surface heats up, causing ice to transition directly from a solid state to a gaseous one through sublimation, bypassing the liquid phase entirely. This process expels jets of vapor and dust, leading to the expansion of the coma and the formation of a tail. The comet essentially comes to life, energized by the immense solar power. At perihelion, this activity reaches its peak. Surface temperatures can rise sufficiently to vaporize materials that were stable mere weeks prior, breaking down complex organic molecules. Ice exposed by erosion on the surface begins to vent. Should a comet be destined to fracture under the strain of thermal stress, perihelion is the critical juncture. 43I/2025 T1 Atlas. Perihelion means experiencing approximately 12 gigawatts of solar power impacting its surface. To contextualize this, it is equivalent to the output of roughly 12 large nuclear power plants, concentrated on an object only a few kilometers in diameter for hours on end. The thermal burden is extraordinary, and the stresses are immense. If 3I/2025 T1 Atlas is a natural comet, we anticipate specific behaviors: substantial outgassing, a notable increase in brightness as more surface area becomes active, a well-defined tail trailing behind as solar wind propels the released material away from the sun, and potentially fragmentation if the nucleus possesses structural weaknesses. This is standard cometary behavior at perihelion, observed countless times with comets originating from our solar system. However, if 3I/2025 T1 Atlas is something else, if the hypothesis of an artificial origin holds any validity, perihelion might unveil a markedly different pattern of activity. This is where the wait-and-see approach becomes unsettling. There is a maneuver in orbital mechanics known as the gravity assist, or Oberth effect. When in close proximity to a massive celestial body, within a deep gravitational well, any alteration in velocity has a magnified impact on one's orbit. Spacecraft routinely utilize this. You would wait until achieving closest approach at perihelion, if near the sun, and then engage engines. The change in velocity at perihelion translates into substantial modifications of orbital energy. It is the most fuel-efficient method for significantly altering an orbit. Now, if 3I/2025 T1 Atlas were to adjust its trajectory, to decelerate and enter a gravitationally bound orbit around the sun rather than continuing on its hyperbolic escape path, perihelion would be the opportune moment. The maneuver would be performed while hidden behind the sun, concealed from Earth-based observation, executing what is termed a reverse Oberth maneuver. Decelerating would mean that instead of passing the sun and exiting the solar system, it would enter an elliptical orbit, remaining within the solar system. Loeb has pointed out that the timing is optimal for precisely such a maneuver. The object would be obscured from Earth, and the thermal and radiation environment near perihelion would mask any signatures of propulsion. If the objective were to conceal a trajectory alteration, this is the time and place to do it. Furthermore, if 3I/2025 T1 Atlas is a mothership carrying smaller probes intended for deployment towards inner solar system targets such as Earth or Venus, its retrograde orbit makes perihelion the ideal point for such releases. The object is moving in opposition to planetary orbital motion. A probe released at perihelion with minimal velocity could intersect Earth's orbit with relatively little energy expenditure. The planet would, in essence, encounter the probe as both objects orbit the sun in opposite directions. This presents a Trojan horse scenario. It appears innocuous, like a comet passing through, behaving as comets do. But at a concealed moment, during perihelion when no one is watching, it performs a different action. It deploys, it maneuvers, it reveals its purpose. Now, does anyone genuinely consider this probable? Most astronomers would answer in the negative. Most planetary scientists would contend that 3I/2025 T1 Atlas will behave precisely as a comet should, that it will brighten, outgas, and possibly fragment, and that upon its reemergence in late November, we will observe exactly what is anticipated, a comet that has survived perihelion and is now heading back towards interstellar space. However, the inability to observe it during this crucial period causes unease. It is a source of sufficient concern that multiple professional observatories have scheduled observations of its reemergence in late November with unusual intensity. It is bothersome enough that space agencies are coordinating to have instruments ready the instant 3I/2025 T1 Atlas becomes visible again. Because here lies the uncomfortable truth. If 3I/2025 T1 Atlas passes behind the Sun as one entity and emerges as something else, we will have missed the transition. We will possess a before and an after, but no during. We will know that a change occurred, but we will not know how, why, or precisely what transpired during those hidden hours. There is a philosophical parallel here, reminiscent of the thought experiment concerning a tree falling in a forest. If an interstellar object performs an unusual action at perihelion and no one can observe it, did it truly happen? But that analogy isn't quite accurate, because we will have knowledge. We will know by what follows. If 3I/2025 T1 Atlas reappears in late November on a different trajectory, with altered properties, or accompanied by smaller objects that were not present before, we will know that something occurred. We simply won't know what terminology to apply. The data from October 3rd, the images we have not yet seen, might provide context for this. If those images suggest that 3I/2025 T1 Atlas is not behaving like a typical comet, then what transpires at perihelion becomes exponentially more significant. It becomes the moment when we either receive confirmation that this is merely an unusual natural object, or we obtain something that compels us to reevaluate everything. 22 days, 3 weeks, and a day. That is the duration until this concealed interval arrives, until 3I/2025 T1 Atlas vanishes behind the Sun and we lose our capacity to observe subsequent events. Until we enter a phase where we must wait and ponder, hoping that when the object reemerges, it remains simply a comet embarking on its journey back to interstellar space. Hoping it has not altered, hoping it has not lingered, hoping that whatever those 7 spacecraft observed on October 3rd was intriguing but explicable, and that perihelion will be equally intriguing and equally explicable. But hope is not data. Hope is not observation. Hope is what one relies upon when the information required to draw conclusions is absent. And currently, as the silence from space agencies persists, as the days count down to perihelion, hope is largely what we possess. That, and the awareness that in late November, when 3I/2025 T1 Atlas reappears, we will finally ascertain whether our hope was justified. Chapter 7. The Nickel Without Iron Smoking Gun. Among all the anomalies associated with 3I/2025 T1 Atlas, one stands out distinctly. One that astronomers find genuinely challenging to dismiss through natural processes. One that, upon understanding the underlying physics, prompts a reconsideration of everything previously understood about this object. It is the nickel, or more precisely, the nickel devoid of iron. Let us commence with fundamental cosmic chemistry. When colossal stars reach the end of their lives, deplete their nuclear fuel, and collapse into supernovae, the ensuing explosion generates heavy elements through nuclear fusion. Carbon, oxygen, silicon, and indeed, metals such as nickel and iron. These elements are forged within the extreme temperatures and pressures of the supernova core, subsequently expelled into space, where they eventually become constituent parts of new star systems, new planets, and new comets. Here lies the critical point. Nickel and iron are produced concurrently. They form within the same stellar strata during identical nuclear processes. They possess similar atomic structures and form bonds in analogous ways. In nature, across every natural object we have ever examined, from meteorites to asteroids to comets, nickel and iron are invariably found together. Their ratio may vary depending on formation conditions, but both are consistently present. Discovering one without the other is akin to finding smoke without fire. It simply does not occur naturally until 3I/2025 T1 Atlas. In July and August of 2025, the Very Large Telescope in Chile conducted spectroscopic observations of 3I/2025 T1 Atlas. Spectroscopy functions by analyzing the light emanating from an object. Different elements absorb and emit light at specific wavelengths, creating a unique spectral fingerprint. The composition of an object can be identified by examining these spectral lines. The VLT detected 22 distinct emission lines of nickel in the gaseous cloud surrounding 3I/2025 T1 Atlas. 22. This is not a subtle signature. It is a strong, unmistakable detection. The comet was generating neutral nickel atoms within its coma, releasing them as vaporized gas from its surface. However, herein lies the predicament. Iron emission lines were zero, absent. Complete absence. The instrument possessed sufficient sensitivity to detect iron if it were present. Other comets observed with the same equipment exhibited both nickel and iron. But 3I/2025 T1 Atlas displayed nickel and only nickel. To grasp the extraordinary nature of this finding, one must comprehend the temperature challenge. At the distances where 3I/2025 T1 Atlas was observed, between 3.8 and 2.8 astronomical units from the Sun, the surface temperature is far too low to vaporize solid metal. Nickel has a melting point of 1,455 degrees Celsius. Its boiling point, the temperature at which it transforms into gas, is 2,913 degrees Celsius. A comet's surface at 3 astronomical units does not approach these temperatures. It might reach a few dozen degrees above freezing, perhaps 100 degrees Celsius under direct sunlight, not 2,900. So, how is 3I/2025 T1 Atlas producing nickel gas? The conventional explanation for comets is that the nickel is not vaporizing directly. It is trapped within other compounds, specifically carbonyl compounds, which can sublimate at lower temperatures and transport the metal atoms along with them. When these compounds break down under sunlight, they release the metal. This is termed the nickel-carbonyl pathway, and it has been proposed as a mechanism by which comets can exhibit metal emissions despite low surface temperatures. This explanation addresses the nickel, but it fails to account for the absence of iron, as iron forms similar carbonyl compounds. If the process is releasing nickel, it should also be releasing iron. The chemistry is not selective. Both metals should appear in comparable ratios to their abundances in the comet's composition. This implies either that 3I/2025 T1 Atlas contains no iron, or that its nickel-to-iron ratio is so drastically skewed, so profoundly different from anything natural, that effectively only nickel is detectable. Here, the situation becomes even more peculiar. The nickel production was not constant. It was increasing dramatically. Between July and August, as 3I/2025 T1 Atlas progressed from 3.88 astronomical units to 2.85 astronomical units, the nickel emission rate escalated 25-fold. 25 times more nickel in a single month. This represents an exponential ramp-up far steeper than typical cometary outgassing patterns. By late August, 3I/2025 T1 Atlas was releasing nickel at a rate described in the scientific literature as extreme. The production rate exceeded that of any comet ever observed at comparable distances from the Sun, and it was accelerating as the object approached perihelion. Now, let us consider the implications of this signature on Earth. When humans endeavor to purify nickel industrially, to obtain nickel free from iron contamination, they employ a process known as the Mond process, or the carbonyl process. Nickel ore is exposed to carbon monoxide at specific temperatures. The nickel reacts to form nickel carbonyl, a volatile compound that can be separated from the iron-rich ore. Subsequently, the nickel carbonyl is decomposed at higher temperatures to yield pure nickel metal. This is the standard industrial method for producing high-purity nickel, utilized in metallurgy, manufacturing, and any application requiring nickel alloys without iron contamination. And it produces precisely what 3I/2025 T1 Atlas is exhibiting: nickel emission without corresponding iron emission. This does not definitively prove that 3I/2025 T1 Atlas, is artificial, nor that it was manufactured. However, it does indicate that the chemical signature we are observing from this object aligns more closely with an industrial process than with any natural process. The spectrum of 3I/2025 T1 Atlas resembles a nickel refinery more than a comet. Could there be exotic natural chemistry that produces this? Potentially. Perhaps formation conditions in another star system might result in metal ratios we have never encountered. Maybe the nickel-carbonyl pathway is somehow selective in ways we do not yet comprehend. Perhaps there is a physical process involving magnetic fields, electrical discharges, or some other phenomenon that preferentially releases nickel over iron. But here lies the challenge to that argument. We have observed numerous comets, hundreds from our solar system, and now 3 interstellar visitors. Not a single one has displayed this nickel without iron signature. If it is a natural process, if it is simply peculiar chemistry arising from an unusual formation environment, why are we observing it only now? Why is 3I/2025 T1 Atlas the sole exception? The scientific paper analyzing the VLT data employs cautious language, as scientific papers should. It characterizes the observations as extremely puzzling. It notes that the presence of both nickel and iron in a cometary coma is already unexpected given the low temperatures. It acknowledges that 3I/2025 T1 Atlas exhibits extreme properties concerning the production rates and abundance ratios of these metals. However, it refrains from stating what every reader of the paper is contemplating. This does not appear natural. It appears engineered. Loeb has been more direct, stating publicly that the detection of nickel without iron is a signature known to exist in industrially produced alloys manufactured through the carbonyl chemical pathway. He has argued that while a natural explanation might be possible, the burden of proof now shifts to demonstrating what that natural explanation could be. Because, at present, the most straightforward explanation that accounts for the observed data involves artificial nickel production. This brings us back to the prevailing silence. If you are a space agency and possess spectroscopic data from Mars orbiters during the October 3rd flyby, you have almost certainly analyzed the chemical composition of 3I/2025 T1 Atlas at a much closer range than the VLT observations. You possess superior resolution, greater sensitivity, and more detailed spectra. What did those spectra reveal? More nickel, still no iron. Did the ratio become even more extreme at closer observation? Did you detect other elements, other compounds, other signatures that render the industrial interpretation more or less plausible? We do not know, because that data has not been released. The VLT observations from July and August are publicly accessible because they originated from a ground-based telescope operated by an international consortium that publishes its data according to standard scientific protocols. However, the data from the Mars spacecraft follows different channels that can be paused, channels that can be controlled. The nickel signature serves as the smoking gun. Not definitive proof, not absolute certainty, but the strongest single piece of evidence suggesting that 3I/2025 T1 Atlas might be something other than a natural comet. And somewhere within the October 3rd data lie observations that either corroborate this signature or contradict it. Observations that might display even more extreme metal ratios or might indicate that, at closer range, iron finally appears, normalizing everything. In either scenario, those observations exist, and we are not being permitted to view them. Chapter 8. The 7 anomalies connecting all the dots. We have been examining individual pieces of this puzzle. The trajectory, the nickel signature, the coordinated silence. Now, it is time to consider the complete picture. For 3I/2025 T1 Atlas exhibits not one anomaly, but 7. And when these are considered collectively, when their interconnectedness is understood, the cumulative weight becomes difficult to disregard. Anomaly 2, the forward jet. When the Hubble Space Telescope captured images of 3I/2025 T1 Atlas on July 21, 2025, something immediately drew the attention of astronomers. The object displayed a visible jet of scattered sunlight extending ahead of it, rather than behind it, which is where cometary tails normally appear, pointing towards the sun. The jet was 10 times longer than it was wide, a narrow, focused stream of material. And here lies the peculiar aspect. For weeks following that Hubble observation, no proper tail developed. The typical cometary appearance, a bright head with a long tail streaming behind as solar wind propels gas and dust away from the sun, did not manifest until late August, nearly 2 months after its discovery. Normal comets develop tails as they approach the sun. The closer they get, the stronger the solar wind, the more pronounced the tail. Yet, 3I/2025 T1, Atlas, initially presented this forward jet, a jet pointing in the incorrect direction. A jet that resembled exhaust from a nozzle more than natural outgassing driven by solar heating. By late August, a faint tail finally emerged. The comet began to resemble a comet more closely. However, that initial forward jet, its 10-to-1 aspect ratio, its unusual directionality, are not typical. While not impossible, they are not what one expects to observe. Anomaly 4, the carbon dioxide dominance. When NASA's James Webb Space Telescope and the Sphere-X Observatory analyzed 3I/2025 T1, Atlas, in August, they detected something remarkable. The gaseous cloud surrounding the object, the coma, is 95% carbon dioxide and only 5% water. This represents an 8-to-1 ratio of carbon dioxide to water. In comparison, comets from our solar system are typically water-dominant. Most comets exhibit a ratio closer to 1-to-1, or even favor water over carbon dioxide. An 8-to-1 ratio in the opposite direction is extraordinary. Now, carbon dioxide ice sublimates at lower temperatures than water ice. Dry ice, as we refer to it on Earth, transitions to gas at -78 degrees Celsius at standard pressure. Water ice requires 0 degrees Celsius. Therefore, a carbon dioxide-rich comet would begin exhibiting activity farther from the sun than a water-rich comet, which indeed aligns with our observations of 3I/2025 T1, Atlas. It was active at 4.4 astronomical units, much farther out than typical comets typically awaken. The question is, why? Why would 3I/2025 T1, Atlas, possess such an unusual composition? The answer likely lies in its formation environment. Different regions of the galaxy, different protoplanetary disks, different ice lines around different types of stars. All these factors influence which materials condense and in what ratios they end up. 3I/2025 T1, Atlas, likely formed in an environment vastly different from the region where our solar system originated. Perhaps around an older, cooler star, perhaps in a region with different elemental abundances. However, here is where it connects to the other anomalies. Carbon dioxide is not merely a different volatile, it is a propellant. If one intended to maneuver a spacecraft using cold gas thrusters, carbon dioxide would be an excellent choice. It is stable, easy to store, and sublimates at accessible temperatures. A spacecraft carrying substantial reserves of carbon dioxide ice could maintain a cometary appearance while possessing ample material for trajectory adjustments. Is this what we are observing? Propellant reserves masquerading as natural volatiles, or simply unusual cometary chemistry? The composition alone does not provide a definitive answer, but when considered in conjunction with the trajectory and the nickel signature, it represents another data point that supports both natural and artificial interpretations. Anomaly 5, the extreme negative polarization. This particular anomaly requires an understanding of how light behaves. When sunlight reflects off a surface, it can become polarized, meaning the light waves align in a specific direction. The degree and type of polarization provide information about the reflecting surface, its texture, its composition, and its structure. 3I/2025 T1, Atlas, exhibits extreme negative polarization. The polarization measurements fall outside the normal range for comets, significantly so. This suggests that the surface properties or the characteristics of the dust grains within the coma are unusual. The object exhibits variations in its form, makeup, and internal arrangement. Negative polarization can manifest with particular kinds of particles. These include exceedingly fine particles, unconventional mineral compositions, unique shapes, and specific orientations. However, profoundly negative polarization is a rare phenomenon, demanding a thorough explanation. Some investigators have posited that this could signify the presence of unusual minerals that formed in the very conditions under which 3I Atlas originated. Others have pointed out that manufactured particles, especially certain types of engineered materials, are capable of generating strong negative polarization. Neither interpretation is definitive, but it represents another characteristic that deviates from the standard cometary profile. Anomaly 7 concerns the alignment of the WOW signal. On the 15th day of August, in the year 1977, the Big Ear radio telescope at Ohio State University captured a potent, narrowband radio transmission at 1420.4 MHz, which is the hydrogen line frequency. This signal persisted for 72 seconds. Its nature was so peculiar and potentially significant that the astronomer Jerry Ian inscribed "Wow" in the margin of the computer printout. This signal has never been detected again, never reproduced, and never adequately explained. The transmission originated from the direction of Sagittarius, with a right ascension of 19 hours and 25 minutes and a declination of -27 degrees. This general direction points towards the heart of our galaxy, where hundreds of billions of stars are densely packed within the galactic bulge. Now, here lies a rather unsettling coincidence. When one traces the trajectory of 3I Atlas backward in time, calculating its position in 1977, it was situated approximately 600 astronomical units away from Earth. Its location in the sky at that precise moment was separated by a mere 9 degrees in right ascension and 8 degrees in declination from the source of the WOW signal. 9 degrees out of 360 degrees around the entire celestial sphere. The likelihood of this alignment occurring by random chance is approximately 0.6%, or about 6 in 1,000. Could 3I Atlas have been the source of the WOW signal? If it were at 600 astronomical units, the required power output would range between half a gigawatt and 2 gigawatts. This is comparable to the output of a typical nuclear reactor on Earth. While this represents substantial power, it is not beyond the realm of possibility. Furthermore, the signal exhibited a blue shift, indicating that the source was approaching Earth, which aligns perfectly with 3I Atlas's trajectory. It is conceivable that the WOW signal was a radar pulse, a sweeping beam traversing space, emitting pings to nearby star systems to identify planets. And by chance, we happened to be within the beam's path for 72 seconds as it passed by. If 3I Atlas detected planets within our habitable zone during that sweep, it might have subtly adjusted its course, accelerating its approach to reach us sooner. By the time of its arrival in 2025, it would have been in transit for 48 years since its detection in 1977. Of course, the entire alignment could be pure happenstance. 6 in 1,000. Unlikely, yet not impossible. This is another piece of data that can be interpreted in either fashion. When considering all 7 anomalies collectively, we gain a more comprehensive understanding. Individually, each anomaly can be attributed to natural explanations. The size might be a statistical anomaly. The forward jet could be an unusual pattern of outgassing. The nickel signature might stem from exotic chemical processes. The prevalence of carbon dioxide could be a consequence of its formation environment. The polarization might be due to peculiar dust properties. The trajectory could be attributed to random chance. The alignment with the WOW signal might be coincidental. However, when all 7 anomalies are considered together, the naturalistic explanation begins to necessitate an increasing number of caveats and a greater number of improbable circumstances that all happen to coincide with the same object. While not impossible, it is highly improbable. And the more factors you accumulate, the more improbable the scenario becomes. Dr. Avi has assigned 3I Atlas a rating on his loeb scale, which ranges from 0, indicating a definitively natural origin, to 10, signifying a definitively artificial and potentially hostile source. He currently places it between 2 and 4, meaning it is not considered 0, not automatically natural, but not yet high enough to warrant any definitive pronouncements. It rests squarely in the ambiguous middle ground, where additional data is required for a conclusive determination. And this is precisely our current position, where we have been since October 3rd. We remain in this ambiguous middle, awaiting data that exists but has not yet been disclosed. We are waiting for space agencies to break their silence. We are waiting to ascertain whether these 7 anomalies, upon close examination by 7 spacecraft, will be explained away by natural processes, or if they will be corroborated by further observations that render the artificial hypothesis increasingly difficult to disregard. The data is available. The observations have been made. The analyses have been completed. Somewhere, individuals are aware of whether these anomalies will be resolved or amplified under closer scrutiny. They know what the images from October 3rd depict. They know what the spectral analyses reveal. They know what the thermal signatures indicate. They possess this knowledge, and they are not yet sharing it with us.